Welcome back to Knowledge Bytes. In our previous episode, we explored recurrent neural network or RNNs and learned how they process sequential data. But RNNs have a major limitations. As sequence become longer, they start forgetting important information. So, how does AI remember something that happened hundreds of words earlier? The answer is LSTM, long short-term memory. Today, we will discover how LSTM work, why they were invented, and why they became one of the most important breakthrough in deep learning. Let's get started. And now, why do RNNs forget? Imagine reading a book of even after many chapters, you still remember the main character introduced at beginning. Human naturally maintain a long-term memory. Traditional RNNs struggle to do the same. As information passes through many steps, earlier details begin to fade out. Eventually, important context gets lost. This challenge motivated researchers to create a smarter memory architecture. So that's where we comes to the LSTM. So what is an LSTM? LSTM stands for long short term memory. It is a specialized type of recurrent neural network designed to remember information over long period. Think of it as a smart memory system. Instead of remembering everything, it will selectively decide it. So, what should be remembered, what should be forgotten, and what should be used right now. So, this selective memory makes LSTMs much more efficient than the traditional RNNs. So why was LSTM invented? LSTMs was created to solve one of the biggest problem in deep learning, that is a vanishing gradient problem. So during training, neural networks learn by passing information backward through many layers and time steps, right? So as we learn this one, as the sequence become longer, the learning signals becomes weaker. So eventually, earlier information almost disappear. As a result, traditional RNN struggles to learn long-term relationships. So now, LSTM was specifically designed to overcome this limitation. So long-term memory challenge. So let's look at a simple example. The capital of France is Paris. Now imagine many words, sentences, or even paragraphs appears forward after forwards, right? So later we encounter the statement the Eiffel Tower is located in blank, right? So to answer correctly, the model must remember that Paris was mentioned much earlier. The important information appears at the beginning, but the prediction happened much later. This ability to connect information across long distances is called a long term dependency. And this is exactly what LSTMs are designed to handle. Right now, the cell state. So, the secret behind the LSTMs is something called the cell state. Think of it as a memory highway. Important information can travel through this highway as long as time without being lost. So unlike traditional RNNs, which continuously overwritten memory, the cell state preserves important context across many time steps. This memory highway is one of the key innovations that makes LSTM so powerful. First one, the forget gate. The first gate inside the LSTM is the forget gate. Its job is simple: decide what information should be forgotten. Not everything we encounter is important. Some information become irrelevant over time. The forget gate removes unnecessary details and keeps its memory focused on what truly matters. You can think of it as a smart filter that cleans up memory. Now, next one is this input gate. The second gate is the input gate. Its responsibility is deciding what new information should be stored. Right? When the model encounters important facts, patterns, or context, the input gate allows them to into the memory. For example, if the model learns that Paris is the capital of France, that information worth remembering. So the input gate acts like a security checkpoints, allowing valuable information to enter the cell state. So now the next one is the output gate. The third gate is the output gate. So its role is deciding what information should be used right now. The cell state may contains large amount of stored knowledges. but not all the relevant for the current predictions. So the output gate selects the most useful information and passes it forwarded. So this helps the model generate accurate predictions and responses. So how LSTM work? Now let's put everything together. As LSTM follows three-step process. First, the forget gate removes irrelevant information. Second, the input gate stores new important information. The third one, the output gate decided what information should be influence the current prediction. So meanwhile, the cell state continuously carried important information through time. Together, these components create a powerful memory system that remember what matters and forget what does not. So that's where. So now let's come to the RNN versus LSTM. So how does LSTMs compares to a traditional RNN? RNNs have limited memory. LSTMs are designed for long-term memory. RNN struggles with long sequences. LSTM handle them much more efficiently. RNNs are highly affected by vanishing gradient problems, but LSTM significantly reduce this problem. Think of RNN as a basic notebook. Think of LSTM as a smart notebook that organizes or preserves and retrieves important information. So now compare with the real world applications. LSTMs became widely used because many real world problems involved in sequences. So, for example, speech recognition system use LSTMs to understand spoken language. Translation system like a translation system use them to preserve context across sentences. Same way, chatbot use them to remember conversation history, and financial system use them for the stock price forecasting, right? And healthcare system use them to analyze the patient data. Weather forecasting system use them to detect the long-term patterns. Wherever sequence and memory matter, LSTM can provide rules. Now, next one, evaluation of AI. LSTM was a major milestone in AI evaluation. So, the journey began with the traditional RNNs. LSTM improved memory and the sequence understanding. Then came transformers. This is very important. So transformers introduced attention mechanism and dramatically improved scalability. Today, modern large language models such as ChatGPT, Claude, Gemini are based on the transformer architectures. LSTMs serve as a bridge between earlier sequence models and today's generative AI revolution. So now come to the AWS AI connections. So understanding the LSTMs also help understanding the AWS AI services. Amazon Comprehend analyzes text and extract insights. Amazon Transcript converts speech to text. Amazon Bedrock provides access to fundamental models and generative AI capabilities. While modern foundation models rely heavily on the transformers, many of the sequence learning concepts oriented from architectures like LSTM. So understanding this evaluation strengthen your AWS AI practitioner knowledge, right? So now come to the our understanding. So let's test your understanding that which architecture was specifically designed to solve the vanishing guardian problem. The option A is CNN, option B is decision tree, option C is LSTM, D is linear regression. As we know, the Vanyan gradient problem was in the RNN. So to the LSTM was introduced or to overcome that vanishing guardian problem. That is where we learned about that. So now LSTM introduced the cell state and three gates to preserve important information across long sequences while reducing the impact of the vanishing gradient problem. So that's where the actually LSTM is the answer. So now key takeaways. Let's summarize what we learned. So LSTM stands for long short-term memory. It is specialized from recurrent neural network. It was designed to solve the vanishing guardian problem. Its cell state acts as a memory highway. It uses three gates: forget gate, input gate, and output gate. LSTMs are widely used in speech recognition, translations, or forecasting, or many other applications. Most importantly, they lay the foundation for the next major breakthrough in AI. So now comes to the end. Thank you for joining me for the episode 13. Right? Today we explored how AI remember the information using the LSTM. So we learn about the long-term dependencies, cell state, forget gate and input gate, output gate, real world applications too. In our next episode, we will explore transformers, the revolutionary architecture behind the ChatGPT, Claude or Gemini, and today's most advanced AI systems. We will learn how attention mechanism changed AI forever. If you found this video helpful, don't forget to like, share, and subscribe. Thank you. See you soon.